All right, so we're going to do the notes for 510 and 511 now, and this is about optimization. This is where we want to maximize or minimize something. Like people who own companies want to maximize profits and minimize costs. So this is something that calculus is used a whole lot for, and we're going to have the Unit 5 test next week, probably Thursday, I'm not sure, but around Thursday. All right, so what is optimization? So it tells you this is one of the most common uses of calculus is to optimize your product. So we have a manufacturer who wants to design an open box having a square base and a surface area of 108 square inches. So in other words, we know the surface area, and we want to, what dimension should we use to should the box be in order to produce a box with maximum volume? So a prism, hope we know a prism is volume equals length times width times height. But in this case, your bottom is a square. So if you look here, that's x and h. So the main equation that we want to maximize is volume, which length and width are the same. So the x times the x is x squared times h. This is the equation that we want to maximize. So the other thing we want is surface area. They say we want to have a surface area of 108. So surface area, if you don't know, is the two bases. So the base down here is a square, and that's a square, which is x squared, all right? And then you've got this side here is, to get the lateral edges, if you remember this from geometry, is x plus x plus x plus x, which is 4x times the height is 8 are the lateral areas. And let me see if, now this does not say if the box has a lid or not. Manufacturing zone, oh, it says an open box. So we have an open box, which means no lid, because this top is open. So the surface area is going to be one base, which is the bottom, plus the perimeter of the base, which are 4x's going around times the height. That's the surface area. And we want this to be 108 area, is what it tells us right here, 108 square inches. So what we want to do is we want to take our secondary equation and we want to solve this for h. And then we can plug this in over here for this h, and then we can have all the variables down to one variable, and then we can do our derivative rules to find all this stuff. So we need to, first of all, subtract x squared from each side. And then we want to divide by 4x. So h is going to be 108 minus x squared all over 4x. Okay, so we can take this value and plug it in for this h, because our goal is, after we get our deal that we're trying to max or min, so this says max volume, so this is our main one, we want to get this all in one variable by using the other secondary equation we get, which in this case was surface area. So I get to take this as x squared, and I'm going to stick in here 108 minus x squared all over 4x. Now I would simplify this whole thing first. So I hope you can see that we can reduce this x with one of these x's. And what that's going to mean is I'm going to have a leading coefficient of a fourth. This 4 I can bring way out in front. And then I'm going to distribute this x to both of these. So this would be 1/4 times, let me get this better, 1/4 times, and then we'd have 108x minus x cubed. So there is our primary equation right there. So we are going to do the derivative of this. So dv dt is going to be, leave your coefficient the same, and then we'll come in here and do the derivative of 108x is 108 minus 3x squared. So this thing right here is my derivative. So we want to now get the critical numbers for this thing. So we're going to set, one is where we want to know where b prime is 0, and the other is if b prime were undefined. There's no variable in the denominator, so there's nothing for this. So we're going to take 1/4 times 108 minus x, 3x squared equals 0. I'd multiply by 4, so I get 108 minus 3x squared equals 0. I'd add 3x over, so 108 equals 3x squared. And I'm going to divide by 3. So let's see, 3 goes into 10 3 times, 18 6 times. So I get x squared equals 6. And that's going to give me that x can equal a positive or negative 6. Now, something we need to keep in mind is we're talking about lengths of a box. So when we're talking about lengths, you never use negative numbers. So maybe something you would want to remind yourself is that x has to be greater than 0. Because if x is not greater than 0, you don't have a box to deal with. So our critical number is 6. Now our goal is to find out, is this going to be our max or min? So what I would recommend we do is the first derivative test. So I'm going to put a 6 here, and I need to put a number less than 6 in here to this equation to find out what kind of number I get. So let's put 1 in here. So 108 minus 3 would give me a positive number, so this is positive. If we put 7 in here, that's 49, and 49 times 3 is going to be 100 and almost, let's see, 7 squared, 49, 50 times 3 would be 150, so this is majorly negative. So our f prime changes sign from positive to negative of 6, which does give me a maximum there. So that's going to be my max right here, okay? So because f prime changes sign. Another thing we could have done is we could have done the second derivative test. We could have done another derivative of this thing, of this right here, done the derivative again, and found out what the concavity was of the second derivative of 6, but I like this way better. So what I'm going to do is the max is going to equal, and we're going to plug in, let's see, if I get 6 here, I got to plug this in here to find out what h is. So h is going to be 108 minus 6 squared all over 4 times 6. So let's see, we get 108 minus 36. Let's see, 100 minus 36 is 64 and 8. 64 and 8 is 72 divided by 24. That is going to be 3. So our maximum dimensions and I would probably say max by first derivative test. Dimensions are, if you remember the dimensions of this thing, there's 3 of them. There's x by x, so our x is 6. They're going to be 6 inches by 6 inches by this h we found 3 inches will be the maximum dimensions. So this right here would be the max dimensions, or the dimensions, I should say, the dimensions of this will maximize the volume of our box. Okay, going on to the next page. All right, so they're showing you here that we can have different size of boxes that all have, get this screen so I can read it. Okay, so there, like it says in the direction there, it says there are many different possible types of boxes with varying dimensions, which give you different volumes. So whenever we're going to do these max min things where we're optimizing, the first thing we want to do is identify the quantities of each part that we're given. So if you can, make a picture. What are the primary equations? So this is going to be the thing that we're going to max or minimize. And then we want to be able to give a secondary equation to substitute into this primary, so we only have one variable. And then we want to make sure that we have a possible solution to this. In other words, we've got a critical number that will work, and then we want to get our desired max or min depending on what the derivative test tells us. So which points on y equals 4 minus x squared are closest to 0, 2. So when you're thinking of closest, I hope something from Algebra 1 comes into your mind. What I'm hoping that is I'm hoping that is distance formula. So anyway, I'm going to graph this thing. So if I plug in 0 for y, I get positive -2. So this parabola hits -2 and 2. If I plug 0 in for x, I get out 4. So this parabola does something like this. That's not a perfect drawing, but you get the idea. And it keeps going, but I hope we can tell that from 0 to 2, or 0, 2 to somewhere over here, it's going to be closest somewhere in this area. Okay, this is what we want to find. We want to find what points are going to be closest to this point 0, 2. So our primary function here is going to be that distance equals the difference in x squared plus the difference in y squared. So this is going to be x minus, and this point right here being 0, 2, because I'm doing from this x or from over here, x minus 0 squared plus, and then we would have y minus 2 squared. Because I don't know what this xy is right here. There's an xy right here that I don't know what it is, so that's this xy. Okay? And then our secondary equation is the one they gave us, this one right here. So since y equals 4 minus x squared, I can take 4 minus x squared and stick it in there for that y right there. So when I do that, I'm going to get tell you what, it might be easier. Let's go ahead and do this. Let's go ahead and simplify this. So this is x squared plus, this would be y squared minus 4y plus 4. Let's see, do we want to stick that in there, or do we want to solve this for x squared and stick that in here? I tell you what, it might be easier if I solve this for x squared and we solve for y. It really doesn't matter. Trying to decide what I want to do here. I tell you what, we'll go ahead and keep it in x squared. So I'm going to take this 4 minus x squared and stick it in there, and that way the algebra is almost done for us. So I got 4 minus x squared minus 2 squared. And then I can combine like terms there, and I'm going to get the square root of x squared plus, and I have 2 minus x squared. And then I think I'm going to go ahead and, I don't know, simplify this thing maybe, or do we want to just use this? Oops, that's x squared right there. I think I'm going to go ahead and simplify this whole thing here. So this is going to be x squared, and then when I do a binomial square, I square the 2, and I take 2 times negative x squared and square that, so that'd be negative x to the, negative 4x squared. I take 2 times negative x squared times 2, and then I square negative 2, and that's going to be plus x to the 4th. And then if I get like terms here, I'm going to have x to the 4th minus 3x squared plus 4. So right there is my distance formula in 1x. Okay, so I want to do the derivative of this thing. So I'm going to come down here and do derivative of d with respect to x. And I need to think of this thing as being x to the 4th minus 3x squared plus 4 to the 1/2 power. So I'm going to do chain rule. So I'm going to take a half in front, leave the inside the same, and subtract 1 from the power, and then go inside here and do the derivative. So this would be 4x cubed minus 6x right there. And then I can rewrite this as 4x cubed minus 6x all over 2 times x to the 4th minus 3x squared plus 4 to the 1/2, which, let's go ahead and make this a square root, like that. And I see there's a factor of 2 in the top, so I'm going to go ahead and reduce everything by 2, the top and the bottom, and then I'll have to worry about that number in the bottom. So there is my derivative right there. So I need to find my critical numbers. So 1 is where The derivative of the distance is equal to 0. So that's going to be where 2x cubed minus 3x equals 0. So let's factor an x out. Oops. So I factor x out of both those. I got x and 2x minus 3, 2x squared minus 3. And I set both of those equal to 0. X, sorry. And then I'm going to add 3 over and divide by 2, so I get x squared would equal 3/2. And then going on down, I square root that, I'm going to get x would equal a positive or negative square root of 3/2. Now, x equals 0 is another possible critical number, so I got to worry about that. So I'm going to do my number line for d prime. And I've got a negative radical 3 over 2 here. I've got a 0 here, and I got a positive radical 3 over 2 here. Okay? So I need to plug in numbers on all sides of these to see where my minimum is going to be. So I hope you know the square root of 4 is 2. So this is a little less than 1. So I'm going to stick in a negative 0.5 here. I'm going to stick in a positive 0.5 here, and over here I'm going to stick in a negative 1, and over here I'm going to stick in a 1 to see what my signs are. So if I stick negative 1 in here, so negative 1 cubed is negative 1 times 2 is negative 2. Negative 3 times negative 1 is 3, and that's a positive on the top. And then down here on the bottom, I got negative 1 to the 4th is 1. Negative 1 squared is 1. So 1 minus 3 is negative 2 plus 4 is square root of 2, which is positive over positive. So I have a positive right there. Okay, then I'm going to come over here, and I'm going to, oh, I forgot to do d prime is undefined. D prime is undefined would be where this bottom part would equal 0. Well, this is going to be a swing stroke above the x-axis. So there's nowhere this will equal 0. If you factor this, you're going to get positive negative 1 and positive negative 4. Actually, positive negative 2. So there is none for this undefined. I forgot to do that part. All right, so we get a positive here, and then we make sure I got the right number here. So let's see, negative 1 cubed is negative 2, and that's 3, so that's a positive. And down here, you can't do a negative here. This doesn't exist. Tell you what, negative 1.7. Let's put in negative 2. I'm not sure negative 1 is going to be the best number. Let's try negative 2. So that'd be negative 8. Negative 8 times 2 makes us negative 16. And negative 16 plus 6. Okay, I was wrong. This is a negative. Okay, so this is going to be a negative out here. Okay. So let's come in here and find a value in here. And again, I'm going to try negative 0.5, negative 1/2. So negative 1/2 to the third is a negative 1/8. So this is negative 1/4. So that's negative 1/4. And then negative times a negative is a positive 3/2. So this is positive on the top. And then we always got positive on the bottom. So that's positive. Let's try 1/2. So if I put 1/2 in here, this becomes a positive, and this becomes a negative. So now this is negative on top, and we're always positive on the bottom, so that's negative. And let's plug 2 in. So if I plug 2 in up there, I get 16 minus 6. 16 minus 6 is a positive over a positive, so we have positive. So our minimums are going to occur where we go from a negative to a positive on the chain, on the sign change. This would be a maximum right here. So relative max. So I am worried about, these are my two x values that are going to give me my minimum. So x equals negative radical 3 over 2, positive and negative radical 3 over 2 are the x values that are my minimum values. So Let me reread the question. It says, which points on the graph are closest? So we are actually going to have to find those points. So I need to plug in f of radical 3 over 2 into my original equation, which I got to find it again. Let me go up and look real quick. So we're going to plug it into right. I think I want to just plug it into this one. I guess I could do this one. We can plug it into that one right there. So I'm going to plug it into this one. So this is going to be the square root of radical 3 over 2 to the 4th minus 3 times radical 3 over 2 to the 2nd plus 4. Now something I want to show you is if you take a positive or negative radical 3 over 2 to the 4th and to another even power, then both of these are going to come out the exact same. So when I simplify all that mess, this in here comes out to be 5 over 2. So the points closest to 0, 2 on the graph y equals 4 minus x squared are radical 3 over 2, 5/2, and negative radical 3 over 2, 5/2. Okay, I think I'm going to quit there for the day, and then I'm going to do some more of these notes for you later.